right, today I got a couple of demos for you guys. Let me mute that one. All right, so what I got here is I got the good stuff here, 95% ethanol. Yeah, we got the good stuff today. So do you guys know the common name for the stuff is typically Everclear? I believe that stuff is like 180 proof, something like that. So if you're ever wondering what the proof means on an alcohol, it's basically the percent concentration by mass times 2. So this stuff would be 190 proof, where 200 proof is 100% alcohol. So this is our typical lab alcohol. The other 5% is why we can't drink it, unfortunately. It's a mixture of water and methanol that's in there. And when they add the methanol to it, they're called denatured. So that basically means that you can't drink it anymore. It'll make you go blind. It's highly toxic now by adding that stuff to it. And let me go ahead and put some gloves on just in case. And I'm going to do a little bit of acid-base chemistry for you guys today. The only reason why I'm using ethanol instead of water here is because acid-base reactions happen a little bit faster in alcohol, so it makes the demo a little bit more enjoyable rather than watching for an hour for it to happen in water. It happens in seconds in ethanol. So I'm going to add an acid-base indicator to it. Just give it some color. This particular indicator is called bromothymol blue. And this is actually the reason why I'm wearing gloves, is because it does stain your skin. That's really the only reason why I'm wearing the gloves. Everything else in here is pretty safe to work with. And I just want to get enough color in there where it shows up really well. I can fix the lighting. All right, just more. This is definitely more than you typically use. I just want to make sure the color is really dark and we can see it really well. All right, so next thing I'm going to add here is a little bit of hydroxide. I probably don't even need any actually, but it's already blue. Let me just put a drop in there just to make sure. So this is a 10% sodium hydroxide, NaOH. And right now is the solution, is it acidic or basic, do you think? Or alkaline? It's alkaline because hydroxides are alkaline. And all I'm going to do now is put a little straw in there and blow into it, see what happens. You guys see that? Are there any ideas? So what happened? What do you guys see? Did it change color though, right? So this indicator, it turns blue in base and yellow in acid. It's one of the components of that mixture. We did the rainbow. This is actually one of the compounds that's in there. And I can actually get it to go back to being alkaline by putting just a drop. Oop. Yeah, we get more of a green color. So what do you guys think was causing, like why did it turn acidic?
Carbon dioxide.
Yep, when you exhale a carbon dioxide, and it just shows you that when that carbon dioxide goes into a solution, it can make it acidic. And that reaction we did go over a few times already. That's when you have carbonic acid becomes CO2 and water. That reaction is reversible. So it's water and CO2 becomes acidic. Let me see if we can do it again. Yep, we're green now. So it's funny, when I first started doing this demo, I learned that you need to actually use a tube and not just blow directly into it, because I actually got drunk the first time I did this demo just by breathing the fumes in. That's actually enough to get you drunk, is breathing the fumes. So yeah, it worked pretty strong. Just make sure that you use a straw. Do you have any questions about that? So later this semester, I think it's coming out pretty soon, I have that discussion about ocean acidification. I mentioned it a few times. I wanted you guys to do the discussion actually online before we talk about it a little bit more detail. But the main thing that I'm kind of going on in that video, or in that discussion, is about how we're constantly giving off CO2 from our cars by burning hydrocarbons to fuel our vehicles. And then that CO2 goes into water and does this kind of chemistry. So I know some people are in denial currently about the acid-base chemistry from CO2, saying it's fake. But I literally just showed you in about 5 minutes that it's not fake. So CO2 is what's causing the acidic solutions here.